Oh, good morning everyone. It is the morning, starting now. As I say, I put on some interesting bits and pieces. Today we've got an alarm clock come desk light from Japan. It's several years old. It's one I picked up from an auction many years ago. It's got one or two interesting features. I'll go through the basic stuff. I'll have to move it about because it's a bit difficult to get it in focus and all that. You've got your normal digital type clock. It's on the numbers actually rotate round. There's nothing technical about it, it's just on like a roller. Hoping I can show it changing. Yeah, I can set it up by the two knobs at the side. You've got the things to set it up, and the knob at the side is, turn it round, is off and on. That's the alarm. So that's an alarm clock. Bench light, as I said earlier, and the normal buttons at the top there. You've got your off, low level of light, high level of light. Now, being Japanese, it has the Japanese plug, which is very similar to the American one. Also, on the base, at least I think it's on the base, yes, there we are, you've got a control there. So I'll turn it round so it's up the right way. It says 50 Hertz, 60 Hertz, and it's adjustable. So by throwing that little switch across, you can change from 50 to 60 Hertz. Now, the reason for this is that in Japan, they use, depending on whereabouts in Japan, either 50 or 60 Hertz. Most of the world uses 50, and the history of the AC goes back many years now to two main gentlemen that comes to mind. In America there was Nikola Tesla, who argued and won the argument with Edison. Edison was all for DC, which will not transmit very far. AC, on the other hand, will. It uses what is known as a skin effect. That is, it uses, if you think of a cable going along, it actually uses the outer layer or the outside of the cable. It's hard to explain, but that's basically what it is. And higher the frequency is, the more of the skin effect comes in. And needless to say, you can only transform AC as opposed to DC, which you can't. So with AC, you can transmit over long distances by having the voltage very, very high. In England, a similar thing existed. You had two gentlemen, both very clever. You had a Mr. Crompton, some of you might recognise that name, made motors, electric lamps and various things. Colonel Crompton, he was said a very clever man, but he was for DC in England. But another gentleman, Mr. Ferranti, saw the advantages of using AC, and through these two people, Tesla and Ferranti, the world changed over. Well, not necessarily changed over, but the pioneers in electric transmission and currents changed over to AC. Anyhow, I'm getting off the subject, I apologise. Now, probably guess now that this type of clock, an electric operated clock, they're a little bit of the past now. Years ago they were quite plentiful. They had to be plugged into the mains, as I just stated, and they were normally fairly small. They could be used as an alarm clock, wall clock, but they've gone out of fashion a bit because of modern techniques, quartz, some other movements. There is a Bolivar type movement which are quite collectible that uses the tuning fork. If I've got one, I could probably put it up. At this stage I'll just concentrate on the electric clock. Now, as I said, they rely on the frequency. The motor is a synchronous motor, no brushes. It's a magnet it's a motor which operates within a magnet, and it starts to turn as soon as it's connected up. But unfortunately, it could either turn one way or the other. So with clocks and things like that, you have a device, a little spring attached to it. If it should start to go one way, which is the wrong way, it causes it to go the correct way. Any other info on synchronous motors, I'm sure there are some very good examples on YouTube, and I will not really go into it now, but suffice to say that this is the lamp which we talked about. It works on frequency. Japan has two systems, 50 cycles and 60. 60 is probably based on the Americans. They've got 60. The rest of the world, or best parts of the world, are on 50. Well, this little item will work on both. There's a little symbol there. It's obviously some association or something, but a lot of odds and ends from this era. I would say this is probably 1960s. It's fairly old. It's not ancient, but it's fairly old, and it still works. Unfortunately, it does make a grinding noise, so it probably needs a little bit of lubrication, but with great care. And also, what I should mention, and should have mentioned earlier, by seeing the plug, which is very similar to the American plug. This is on 100 volts, not 110 or 120, but 100. Japanese stuff tended to use 100 volts. So obviously if you use it over here on AC, make sure it's through a transformer. Anyhow, I hope I've explained everything you need to know. The light inside it is just a normal tungsten lamp. It's got an unusual base though. Being Japanese, it's got a non-standard base. This size is often used for Christmas lights and that in America. It's a little bit larger than the small Edison screw, but they are obtainable. And as I say, it's this bulb's quite a low wattage one. I think it would take up to about 40 watts. So it gives a nice bit of light, particularly on your bedside. Anyhow, thanks again for watching. Any questions, please ask. Please subscribe. Please comment. Good or bad. It's all publicity. So thanks for watching. Thank you.